I'm going to present some recommendations I have for protection of data in organizations on their disks in their databases. So I've mentioned this in a few videos before that I've made, and of course I've implemented it myself, and it makes part of the entire suite of things that you'll need to protect data, uh, which include on the protection of data on the so-called on a wire out on the internet, and even within organizations on their wires. But this is what I recommend for protecting data uh, in the databases, basically. So, database is are separated into rows, uh, columns and rows, and in each row you might have like address or phone number, important things that nobody really should know unless they absolutely have to. And several people have access to this information regularly, though they generally have to get approval for it. Some they may only need access to a little bit of it, and they certainly hardly ever need access to specifics like a person's address, their name, and stuff like that. So those people are like DBAs. DBAs that will manage the database. It's a any large organization is going to have tons and tons of data. That the database management software is going to be very large. The database itself is a very large file. So this also has to be managed by technical people, and you'll have several of them, if not thousands, at a very large organization. So and they will be approved by some process, but this process I don't think is anywhere near thorough enough to give them access to personal information like your name and your address and your salary, etc., your phone number, your email address. So there needs to be some way that they can do all this management. They can look at all the rows without seeing specifics, and that's what I'm about to present. But anyway, more people are, you have the DBAs, more people are software engineers practicing, uh, inspecting the results of their work when they write, software. It will edit this, and they have to have a look at it. Account managers, customer service managers, account managers will need to see some of it. They'll need to see, maybe A's data and B's data and C's data, but then they may never, even though they have access, they don't really need to see D, E, and F's data, right? So they get to see too much. And then another one is marketing managers or marketing technologists will mine this data, put it into a big pile, and mine it for interesting things like how many people there are in 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 Tampa or something like that, and they may use demographics too, like race or religion or sex or hobbies or something like that. So it really needs to be. You need a system for extracting the human being from the information that they actually need to see. So what I recommend is almost all data in this database should be encrypted, basically. And as I've mentioned before, encryption is taking one number, applying some mathematics to it, or using it to apply mathematics to a piece of data and come out with a third piece that's basically garbage that nobody can understand. And that's what should be in the database. So you take an encryption key, some real data, like a street name or address, apply those two together with some mathematics, and you'll come out with garbage that nobody can understand, and that's okay to have in the database. Anybody can see that because it means nothing to anybody. So that's one layer of encryption. You'll use an encryption key to do that. So how can you have that data encrypted in the database like that? And only certain people can get access to it, basically. So how can you do that? Well, you'll have the encryption key, and where are you going to put that so that it's not available to everybody, basically. So you have to use what you call password-based encryption, and that's where a person will leverage a password, and you'll do the same thing with this encryption key, and end up with some more obfuscated data. And then you'll store that somewhere. Store that in the database. But that's garbage until you have that person's password. So what you'll do is, however many people need to see this group of data, the machinery will take this key and encrypt it with those people's passwords. So each one of those people will provide a password. The machine will encrypt the database key for this amount of data with their password, and there will end up with 3 lines of data, or not 3, but however many. I've given an example of 3 people, 3 passwords, 3 pieces of data that are encrypted, which are actually the key for this many people. Maybe this is 20 accounts, 20 different accounts of data, and these will have access to it. And then down here, a little while later, you'll have 20 more, and you have a few more people. And you'll do the exact same thing. You have a main key for that data, and you'll have some more people with their passwords, and you'll encrypt that like that, just like you did before. You'll keep this in the database somewhere, and since these are garbage to anybody who doesn't have those passwords, those are free to keep basically anywhere, so no problem. And since you use this encryption key to encrypt that, you hardly need any further security on it. The DBAs don't need to be top secret. Software people don't need to be top secret. It's already redacted. If it ends up in a file, a log file or something like that, it's really just garbage. And you had a buzzword called redaction, means make it obfuscate, make it not interpretable. So encryption based redaction, I guess you call that. One issue is we like to do searches in database on things like names, addresses, numbers, etc. So you will have to do what's called indexes that use this data. It'll have to be resorted based upon this garbage database, basically obscured data, and you'll have to have indexes, and they will be unintelligible to anybody, but you can still sort based on those what the result, and you can have sorting schemes. I've done that with obscure data, and that pretty much makes anybody who sees any of this without the passwords aren't going to see anything worthwhile to anybody, and your data is there with confidential to only people who need to see it. And customers service representatives who only have access to certain amounts of data, and I've never seen this before, is called access control list. I have never seen access control per representative, basically. And this is a way to effect access control, what's called access control lists, to specific consumers of the data. So an example of that might be you have these reps who would work, say, Tampa, and they should only work on people's data who's in Tampa. That's still a lot of people, like 10 million people or something like that. But then they wouldn't see anybody from Jacksonville or Atlanta or Memphis or California or Los Angeles, because they only have the key for data to Tampa. So that's how to use encryption to effect access control lists and to specify what accounts a representative will have access to. Access control lists effected with data redacted with encryption. And one further trick that can be done with this is if you don't want one person to have absolute power over it. We all know absolute power corrupts absolutely. So you want some piece of data only viewed when others are present. So you can still pick a few people. They would still have passwords. They can still have a piece of information that they encrypt with their passwords. Really good passwords. Of course. You still have some chunk of thing you want to access with this key. Decrypt it. You'd only give them a portion of the key. Individually, these pieces are worthless junk, basically. But if you sum them together to make this key, you can then get to the database. So basically 3 layers: passwords, the segmentation, and then you get to this. And you could even add that another layer. This is used to decrypt it, another password. And then you go to the database with that. So that's 3 layers basically. And then it could be like these 3 can get to it, and then maybe another team can either get to this one through another kit. It gets to that. Or they can just get a different one in a different group. So that's how you do that. That's how you restrict access to simultaneous approval. Encryption. Simultaneous approval. Another thing I mentioned is that you should separate the databases into important chunks like personal information and ledger data and geography, basically. Yeah, any organization that's got a bunch of people is going to use geography, basically. So they're already doing that. But if you extract out personal information from ledger information, you use some internal control number to reference the ledger data, then in order for this to be a security violation, a person would basically have to memorize the relationship of control number to people. And if you give people access to personal information like DBA1, but not access to the ledger data, like that'd be DBA2, then they would have to collude to cause any kind of compromise of the security of the data between, to get the whole picture of any person's personal data. So that's also something that should happen, that I mentioned. Anyway, I guess that's my recommendations for how data security should be done inside the organization, in the data center, and not concerning itself so much with what's being shipped across the internet, which is a whole nother matter. That's all.